Hello friends, hello. This is Waghmare, Department of Mechanical Engineering, YB Patil Polytechnic, Akurdi, Pune. So, in today's session, we are going to see uh, unit number 2 of power plant engineering subject, and name of that topic is high pressure boiler. Okay, and marks allotted for this topic are 12 marks. Okay, so before starting this unit number 2, high pressure boiler, I would like to recap whatever you studied in your second year regarding thermal engineering subject. In that boiler, what is meant by boiler, what are the types of boilers, then what is thermal power plant, what are the important components of thermal power plant, boiler mountings and accessories. So all these points in today's session we'll just recap it. Okay, and after this means in coming session we will see the high pressure boiler. Now let us start with this high pressure boiler. So unit number 2, high pressure boiler, marks allotted are 12. Okay, then we'll see syllabus. Why the syllabus is important, why it is necessary to go through the syllabus before starting the unit, any unit. Okay, the importance is that when we go through the syllabus, then we will come to know what exactly we are going to study in this topic. Okay, means overall idea we'll get. Okay, so syllabus is important. So first point we are going to see here is high pressure boilers. Okay, what is meant by high pressure boilers and its classification. Okay, and different types of boilers, high pressure boilers are there, its construction, working. For example, Lament boiler, Benson boiler, Loeffler boiler and Wilcox boiler. Okay, Smith-Hartmann boiler and Ramsey boiler. So all these are the high pressure boilers. We will see it in detail. Then next point is FBC, fluidized bed combustion. Okay, its principle, need, types, various arrangement, control system and advantages over other boiler systems. Okay, this point we'll see. Then next point is comparison of various types of boiler. The next point is IBR, Indian Boiler Regulation Act. This is very important point from your examination point of view. We will see it in detail. Then maintenance procedure of major components of high pressure boiler and FBC. Okay, fluidized bed combustion boiler. Then unit outcomes, means after completion of this unit number 2, high pressure boiler. Okay, so first outcome is explain with sketches working of the given type of boiler. Means after completion of this unit number 2, you will be able to explain with sketches working of the given type of boiler. Okay, then you must be able to compare the salient features of given types of high pressure boiler. Then you will be able to explain preventive maintenance of the given high pressure boiler. Okay, then next outcome is explain the predictive maintenance of high pressure boiler. Okay, so all these are the unit outcomes. So this is actual image of thermal power plant. Now what is steam? Okay, steam is a vapor form of water. When we increase the temperature of water, then the conversion of liquid water into vapor form of water takes place, and that vapor form of water is known as steam. Then what are the applications of the steam or commercial uses or usages of the steam? So first major application of the steam is for power generation purpose or electricity generation purpose. Then heating the residential or commercial building, in cold weather condition, or in other words we can say for air conditioning, right? Then another application in industrial usages, for example chemical industry or sugar industry. Why it is important? Because we cannot use fire or heat directly to increase the temperature of the chemical. Okay, So due to this, what happens, explosion, chances of explosion are there. So to avoid that, we have to use a steam for indirect heating, right? Then next point is, what is mean by boiler? Okay, boiler, it is the equipment used for producing and transferring steam. It's called as steam generator or boiler. Okay, it is working of the boiler is similar to the pressure cooker, which we generally use in our kitchen. Okay, working of the boiler is similar to that. It is one type of boiler. Then working principle of the steam generator or boiler, fluid or water, when it is heated or the temperature of that water increases by burning the fuel, then conversion of the liquid water into vapor form, that is steam, takes place. Okay, and fuel used here are, it may be solid, liquid or gases. Solid fuel in the sense coal, liquid fuel in the sense diesel, or gaseous fuel, natural gas or any other gaseous form of fuel are used as a fuel. Okay, then next point is thermal power plant. Thermal power plant, here we are going to see what is thermal power plant, its important components and its working. Okay, thermal power station is a power station in which heat energy is converted to electrical energy or power. As I told, water is heated, its temperature increases and conversion of the water into steam takes place. This steam drives the turbine and from which we can obtain the electrical energy. In this diagram you can see here main components of the thermal power plant. First important component is boiler, second is turbine, third is condenser, and fourth is feed water pump. Okay, then along with this other components are also there: cooling tower, then chimney, cool hopper, precipitator. Okay, now see it's working. When we heat the water by burning the coal fuel here, the water temperature of the water increases and it converted into high pressure, high temperature steam, and this steam imparts force on the turbine blades. So rotation of this shaft takes place. The shaft is connected to the alternator. The shaft is connected to the alternator or generator, where the electricity is generated, and through the transmission line we can transmit the electricity towards the consumer. Then output of this turbine is high temperature low pressure steam. High temperature low pressure steam is there. This high temperature low pressure steam, we send it into the condenser, where again here exchange of heat takes place in between the cold water which we are sending from the cooling tower. Okay, and it becomes hot. Then here it is conversion of the steam into liquid form, that is condensate. This condensate we store it into the storage tank or water storage well. By using this feed water pump, we again send it into the boiler, okay, where the conversion of water into steam takes place. So in this way the cycle completes, right? Then what about these flue gases? These flue gases, after giving heat to the water, we send these flue gases through this path, okay, in the chimney and into the atmosphere. These flue gases we release it into the atmosphere. Here it is one more component, precipitator. Function of the precipitator is to remove the carbon particles or any solid particles remained in the flue gases. Working of that precipitator we'll see it later. Okay, then here it is cooling tower. Function of the cooling tower to send the cold water inside the condenser and it absorbs the heat from that steam, which is high temperature steam, and it converted into, or not conversion, here it is temperature increase takes place of that water and we send it into the cooling tower. And because of the natural drought here, the water again becomes cold, and this vapor form of liquid we release into the atmosphere, right? Just now we seen it in the first diagram here. Yes, here this is a cooling tower. Okay, these are the two cooling towers where the liquid vapor form of liquid we are releasing into the atmosphere. Okay, this diagram also shows the thermal power plant. Okay, same components. Then next point is classification of boilers. Okay, this is just a recap of uh, thermal engineering subject which you studied earlier in second year, right? Classification of boilers may be classified according to the following types. First parameter is relative position of hot gases and water. Okay, relative position of hot gases and water. First type is fire tube boiler. Okay, means tube is there. Through the tube we send the fire or flue gases and it is surrounded by the water. Okay, it is surrounded by the water. So this type of boiler is known as fire tube boiler. Then water tube boiler. A tube will be there, and through this tube we send the water and it is surrounded by the flue gases. So this is a water tube boiler. Then next classification according to method of firing. Internally fired boiler and externally fired boiler. First type is internally fired boiler and second one is externally fired boiler. The furnace is provided inside the boiler cell, right? So this type of boiler is known as internally fired boiler. Furnace is provided inside the boiler cell and is completely surrounded by water cooled surfaces. Okay. Then externally fired, where the furnace is provided outside or under the boiler. It is not the part of boiler cell, right? So example is Babcock and Wilcox boiler. Then next classification according to pressure of steam. High pressure boilers and low pressure boiler. What is high pressure boiler? If the generated steam pressure is above 80 bar, 80 or 80, above 80 bar, then it is high pressure boiler. If it is lower than 80 bar, then this boiler is known as low pressure boiler. Now these are some examples: Lamont boiler, Wilcox boiler, Benson boiler, Loeffler boiler, Schmidt-Hartmann boiler, Ramsey boiler, and Babcock and Wilcox boiler. Okay. This is our syllabus part. We will see it in detail. All these boilers we are going to see it in detail. Then next is low pressure boiler. Examples: Cochran boiler, Cornish boiler, Lancashire boiler, and locomotive boiler. Then next classification is according to method of circulation of water. Okay, without any external aid, if the circulation of water is taking place in the power plant, then it is natural circulation boiler. And forced circulation means external force or external equipment or device is used to circulate the water throughout the system. So that boiler is known as forced circulation boiler, right? Pump is used. In short, we can say pump is used. Then next is according to nature of service to be performed. Stationary boiler, portable or mobile boiler. Stationary boiler in the sense it is situated at or it is located at one place. We cannot relocate it or we cannot move it. So it is stationary boiler. Then portable boiler means we can move or we can transport from one place to other place. For example, marine application or marine application, and then locomotive application or locomotive boilers, right? Then next classification is according to one-screw boiler. One-screw boiler in the sense the boilers in which no circulation of water takes place. The feed water leaves the tube as a steam Benson boiler means we supply the water inside the system, and the output of the system will be the, yes, output of the system will be the steam. Okay, means in single pass we are obtaining the steam. So that is once through boiler. Then next is position and number of drum. According to position and number of drum, it is a single or multi drum, may be positioned longitudinally or crosswise. Then according to design of gas passages, single pass, return pass and multi pass. Okay. Then next point is essential of a good boiler or requirement of a good boiler. Which parameters, which characteristics of the boiler should be? So first point, heat generation capability should be at required pressure, required quality, fast speed, minimum fuel consumption. Okay, the boiler should generate a required pressure. Okay, whatever purpose we are using the boiler, that much pressure it should generate. Then required quality in the sense, suppose in case of power plant we require a superheated steam, so it should fulfill the required quality. Okay, not saturated steam. Saturated steam means it is a combination of vapor and liquid form. So this type of steam is not required in power plant. Only superheated steam is required. Then fast speed. With fast speed there should be steam generation. Then minimum fuel consumption. Economic. In short, we can say the boiler should be economic one. Okay, cost, running cost or installation cost should be less. Then construction, its weight should be light. Okay, less amount of brick work. Then occupy small floor area. Then quick starting, boiler should be quickly start and quickly shut down. Then capable to meet fluctuating demand of steam supply. It should fulfill the requirement of the consumer load. Then easy availability of spare parts. So these are the some essential requirements of a good boiler. Now next point is boiler mounting. Okay, what is meant by boiler mounting and boiler accessories? This point we'll see here. So what is boiler mounting? The essential parts on the boiler is known as boiler mounting. Essential or necessary part. Okay. The necessary devices installed or mounted for the safety of the boiler and its control are called as boiler mounting, without which we cannot run the boiler. If we try to run the boiler without this mounting, then it will be very hazardous or very dangerous. Okay, so these mountings are essential. The boiler should have two water level indicators. Here some mountings are listed. We'll see in brief after this slide. So two water level indicators should be there. Then two safety valve should be there. Combined high steam and low water safety valve should be there. Fusible plug. Then pressure gauge, junction or stop valve, feed check valve, block cock, manhole and mud hole. So all these are the boiler mountings or essential parts of the boiler, without which we cannot run the boiler. Okay, so first boiler mounting is water level indicator. Okay, water level indicator. Actually there should be two water level indicator. If one water level indicator fails, other water level indicator will be in working condition. Okay, so see here, actually this is a boiler cell. Okay, boiler cell. to this boiler cell, this water level is attached, the water level indicator is attached, upper portion is in contact with the steam portion of the boiler cell, and the lower portion is in contact with the water portion of the boiler. And here it is a this is a glass tube. Okay, this is a glass tube. If its function of the water level indicator is to indicate the level of water inside the boiler cell. Okay, function of the water level indicator is to indicate the level of water inside the boiler cell. The top portion is in contact with the steam part, and the bottom portion is in contact with the water part. Okay, as the water level goes down, then we can see the label here. We can see the label in the glass tube. So according to that, the operator can increase the water level inside the boiler. Okay, then next is pressure gauge. Next important component or mounting on the boiler is pressure gauge. Function of the pressure gauge is to show the steam pressure inside the boiler cell. Okay, this diagram is nothing but a pressure gauge, burn-down type pressure gauge. It is in contact with the steam part of the boiler cell. This steam act pressure on this tube. Here it is elliptical type of tube is there. Because of the steam pressure, some movement of the this rod, mechanical linkages are there. Movement of the rod takes place, and the pointer shows the pressure inside the boiler cell. Okay, then next component is safety valve. Okay, next component is safety valve. First type of safety valve is lever safety valve. Lever safety valve, and second one is the dead weight safety valve. Lever safety valve in the sense lever is used. Okay, and dead weight safety valve in the sense dead weights are used. So function of the safety valve is to maintain the level of steam pressure inside the boiler cell. If the pressure inside the boiler cell increases or it exceeds the limit, then some amount of pressure, steam pressure or steam will release into the atmosphere. Okay, so you can see in this diagram, this is also one type of safety valve, spring loaded safety valve. Here it is, spring is used. This portion is in contact with the steam portion of the boiler. Okay, steam portion of the boiler. As the pressure increases, this lever may try to lift in the upward direction, and the excessive steam pressure will release into the atmosphere. Okay, so in this way it maintains the steam pressure inside the boiler cell. Okay, safety valve, so it is important. Then here it is high steam and low water safety valve. Okay, it controls the high pressure of the steam. If the pressure of the steam is high, then it lowers the steam pressure, and if the water level goes down, then it increases the water level. Okay, so as its name indicate, high steam and low water safety valve. Then next is junction valve, or this junction valve is also known as steam stop valve. Okay, steam stop valve. Function of the junction valve or steam stop valve is to stop or to allow the steam coming from the boiler cell. Okay, so this portion is in, or this valve is attached on the top portion of the boiler cell. Okay, and by using this rod and wheel, we can create opening or closing to the steam, okay, according to requirement. So this is the function of the steam junction valve or steam stop valve. Then next is feed check valve. Okay, function of the feed check valve is to prevent the backflow of water. Okay, prevent the backflow of water from when the boiler or feed water pump is not working. Okay, boiler or feed water pump is not working. It is similar to the non-return valve. means only one direction we can send the water. For example, here we can send the water only in this direction. If the pump is not working or boiler is not working, in that case, this part, okay, this part will rest here again, and it prevents the backflow of water. Okay, it prevents the backflow of water. So that is feed check wall. Then next component is blow off cork or blow off cork wall. Function of the blow off cork wall is to remove the water from the boiler cell while maintenance. Okay, when we carry out the breakdown maintenance of the boiler cell, then it is necessary to remove the water from the boiler cell. Okay, so it create a opening for the water which is inside the boiler cell. So this is the function of blow off cork wall. The next is fusible plug. Okay, if the water level is less inside the boiler cell, then the temperature of that water increases. Because of that, melting of the metal or that fusible plug takes place, and it creates a hole or opening through which water enters into the combustion chamber. Okay, and because of that, what happens, the burning of the fuel or the combustion process stops, and ultimately it stops the working of the boiler. Okay, so this is the function of the fusible plug. And for manufacturing of the fusible plug, metal used is gun metal, okay, which is having a low melting point. Then next point is boiler accessories. Okay, similar to boiler mounting, another point is boiler accessory. Boiler accessories are nothing but the devices which are installed or located with the boiler for efficient purpose or for increasing efficiency of the plant. Okay, these parts are not essential. Okay, these parts are not essential, only these are installed for increasing the efficiency. So which are the boiler accessories? First boiler accessory is superheater, second one is economizer, and then third one is air preheater. Okay, now see, superheater. Function of the superheater is to superheat the steam. Function of the superheater is to superheat the steam. How the superheating takes place? Location of the superheater is in the path of flue gases. For example, here through this pipe, suppose flue gases are flowing. Okay, flue gases are flowing. We generally release these flue gases into the atmosphere, but if we keep this superheater in the path of flue gases, the waste heat is recovered, or it is taken by this steam, and it becomes a superheated steam, and we can utilize that superheated steam for power generation purpose. So function of the superheater is to superheat the steam. Then next component is economizer. Okay, function of economizer is to preheat the water before sending it into the boiler cell. So what happens if we preheat the water? The amount of fuel required to increase the temperature of that water will be more. Okay, so to minimize that required fuel, we need to preheat the water by taking the waste heat which is coming from the flue gases, right? So that is the function of economizer, to preheat the water before sending it into the boiler cell. Okay, and location of the economizer is in the path of flue gases. The next component is air preheater. Okay, for combustion purpose, air is required. If we preheat the air before sending it into the combustion chamber, then the amount of fuel required will be less. Okay, so ultimately the efficiency of the plant increases by using the air preheater. Okay, so these are the three accessories: air preheater, economizer, and superheater. Okay, so this is about the just recap of the thermal power plant and boiler mounting and accessories. So friends, this was just a recap or revision of the thermal power plant and boiler mountings and accessories. Okay, so next session we'll see high pressure boiler. Okay, so thank you for watching this video. Thank you very much.